With everything going on right now around Trump and Iran, I really hope this situation does not turn into something worse. But moments like this have a way of making certain kinds of knowledge feel a lot less old-fashioned. And one of them is the kind of backyard food-growing knowledge American families once treated like a survival skill. And I do not mean that in some cozy, nostalgic, look-how-simple-life-used-to-be way. I mean there was a time in this country when ordinary families were taught how to grow food because it made them more secure, more useful, and a lot harder to shake. Soil, seeds, compost, timing, plant combinations, season extension, that was not fringe. That was not some crunchy side culture. During World War II, that was serious American knowledge. And once you see how serious it was, the rest of the story starts to look a lot less innocent. After Pearl Harbor, Secretary of Agriculture Claude Wickard launched the Victory Garden campaign almost immediately. The government printed millions of pamphlets. NBC carried gardening instruction over national radio. The USDA sent scientists, extension workers, and nutrition experts out to teach families how to grow food in backyards, vacant lots, rooftops, anywhere sunlight and soil could be found. By 1943, roughly 20 million American families were gardening on around 7 million acres. President Roosevelt confirmed that Victory Gardens were producing about 42% of the fresh vegetables eaten in the United States. A Gallup poll found 54% of families were growing food to save money, not to perform patriotism. By January 1944, about 75% of American housewives were canning food, averaging 165 jars a year. Americans bought 315,000 pressure cookers in 1943 alone, up from 66,000 the year before. That is not a hobby culture. That is a country feeding itself. And the methods they were taught are the part that matters here. The wartime manuals did not push families toward a purchase cycle. They taught composting, crop rotation, companion planting, seed saving, cover crops, low-input soil care, and practical pest management as official policy. Not as alternative gardening, not as folklore, as real household infrastructure during a national emergency. So before anyone says this is just romantic hindsight, that question is already settled. The system worked. It worked under pressure, it worked at scale, and it worked well enough that millions of families trusted it with real food, real shortages, and real money. Then the war ended, and the incentives changed. During the war, the United States built 10 new ammonia plants to produce ammonium nitrate for bombs. The Tennessee Valley Authority alone moved around 30,000 tons of anhydrous ammonia and 64,000 tons of ammonium nitrate crystal for munitions. But by 1946, the war was over. The factories were still there. The chemistry was still there, and now all of that productive capacity needed a new customer. Synthetic fertilizer became that customer base. The USDA pushed surplus fertilizer onto farmland. The TVA ran demonstration programs that gave free synthetic fertilizer to 90,000 farms. In the first 15 years, fertilizer sales in the TVA region grew at 3 times the national rate. U.S. fertilizer consumption went from about 2 million tons in the late 1940s to 24 million tons by 1981. That is a tenfold jump in one generation. Today, the global fertilizer market is worth around $200 billion a year. Just 4 corporations control about 75% of domestic fertilizer production in the United States. Between 2020 and 2022, those companies saw profit increases that ran as high as 1,500%, while their costs rose less than 50%. That kind of money does not sit quietly beside a culture of household self-reliance. It crowds it out. Because every time a family learns how to hold moisture with residue, grow fertility in place, save seed, or build soil biology instead of buying another intervention, that family becomes a little less useful to an industry built on recurring dependence. And once that purchase cycle becomes normal, the old knowledge does not even have to be officially banned. It just has to be made to feel old, messy, unsophisticated, or unnecessary. Meanwhile, the consequences keep piling up. The Gulf of Mexico dead zone linked to fertilizer runoff measured about 6,700 square miles in 2024, roughly the size of New Jersey. More than 400 dead zones now exist worldwide. Only about 35% of nitrogen fertilizer applied to crops is actually taken up by plants. The rest escapes into air and water. agricultural runoff remains the leading cause of water pollution in American rivers and streams. So we ended up with a system that trains people to buy more, leak more, and remember less. And that is why these old methods matter. Not because they are quaint, because they describe how living soil actually works. Healthy soil is not just dirt plus nutrients. It is not an empty medium waiting for a product to rescue it. It is a living cycle. Organic matter stays in motion. Fungi connect roots to resources. Bacteria process what falls to the surface. Worms build channels. Plant roots feed the underground life that later feeds the plant back. Moisture, structure, biology, and time are working together all at once. When that system is intact, the garden starts carrying more of its own weight. When you keep breaking it, you get a bed that constantly needs another purchase to stay functional. That is the real divide here. A living system that compounds, or a consumer system that resets. So let's get into the first layer of what they taught. Chop and drop. A lot of people still end the season by stripping a bed clean. Tomato vines get yanked out. Bean stems get hauled away. Squash leaves go into bags. Everything gets cleared down to bare dirt because bare looks neat, and neat reads as responsible. I understand the instinct, especially in suburbia where a garden is always being judged a little bit by the standards of lawn culture. Trimmed. Managed. Finished. But the soil reads that scene very differently. To the soil, that is not cleanliness. That is loss. The forest gives you the simpler model: nothing gets dragged to the curb. Leaves fall where they grew. Branches break where they land. The biology underneath receives exactly what the life above produced. That is the cycle. And once you stop interrupting it, the numbers get hard to ignore. A Kansas study from 1954 found that mulch just half an inch thick cut evaporation by 41%. At 3 inches, evaporation dropped by 67%. An 11-year Ohio State study found that organic mulch increased water holding capacity by up to 35% and moisture retention by as much as 70%. A 10-year study in Inner Mongolia found that leaving crop residue on the soil surface increased yields by 14% and water use efficiency by 13.5%. And the erosion numbers are even more brutal. In field trials from Nigeria, mulched soil lost 0 tons of topsoil per year. Unmulched soil lost 41 tons. Bare fallow lost 230 tons. Same soil, same rain. The difference was whether plant material stayed on the surface or got removed. So when someone bags up stems, leaves, and spent vines, and then turns around to buy mulch in plastic, that is not just a gardening choice. That is a money leak. You already grew the cover your soil needed. You already grew the moisture-saving layer. You already grew part of the erosion control. Then you hauled it away. Cut the tomato at the base and leave the root in. Lay the bean vines down. Let the squash leaves collapse where they grew. Let the bed stay fed. That is not lazy gardening. That is the beginning of a working soil cycle. And once you understand that, the next problem becomes obvious. A lot of modern garden soil is not exactly dead. It is thinned out. Gray, compacted, quiet, disconnected. You push a shovel in and it feels dull. Water runs off too fast or sits on top too long. Plants survive, but they never look like they are fully plugged into the place. That is where one of the most overlooked wartime ideas starts to feel almost radical again. Forest soil inoculation. Not because the woods are magic, because the woods are functioning. A teaspoon of healthy soil can contain somewhere between 100 million and 1 billion bacteria, yards of fungal threads, thousands of protozoa, and tens of thousands of species. That is not poetic language, that is a living workforce. The old Victory Garden manuals recommended bringing a little soil from a healthy woodland area into the garden beds. They knew that soil life could be transferred. They may not have used today's vocabulary, but the principle was already there. Modern science did not embarrass that old instinct, it backed it up. In 2016, researchers at the Netherlands Institute of Ecology published a study in Nature Plants showing that when they applied a very thin layer of donor soil, less than 1 centimeter, from healthy grassland or heathland onto farmland that had been chemically managed for nearly 60 years, the microbes did not just improve the soil. They changed the direction of the whole ecosystem. Within 6 years, plant communities shifted, soil invertebrates returned, and the restoration trajectory changed. In 2023, researchers at the University of Wisconsin published work in Science showing that trees inoculated with microbes from climate-matched sites were at least 50% more likely to survive severe stress, and those transplanted microbes were still detectable in the roots 3 years later. That is not a boutique gardening hack. That is a documented reminder that biology can be restored, and that once it comes back, it starts changing everything around it. And that leads straight into the underground partnership most people have never really been taught to think about: mycorrhizae. Around 80% of land plants form partnerships with underground fungi. The plant sends sugars down into the root zone. The fungi extend outward through the soil, reaching water, phosphorus, nitrogen, and trace minerals that roots alone would reach more slowly or not at all. A 2024 meta-analysis covering 187 studies found that mycorrhizal fungi increased phosphorus uptake by 105%, nitrogen uptake by 67%, and overall plant biomass by 47%. In wheat, these fungi can deliver 50 to 80% of the plant's phosphorus, even when there is no dramatic visible difference above ground. Globally, mycorrhizal networks are estimated to help sequester around 5 billion tons of carbon a year, so when a garden looks alive, that life is not only in the leaves. A lot of it is happening in the handshake below. And a lot of modern habit works directly against that handshake. Heavy tillage shreds fungal threads that took months to build. Long stretches of bare soil starve the organisms that rely on living roots. High-phosphorus synthetic fertilizer can suppress mycorrhizal colonization because the plant starts leaning on the bag instead of maintaining the partnership. Fast convenience on the surface, weaker biology underneath, that is what makes no-till mound planting so important. For a long time, indigenous growing systems that avoided plowing were treated as primitive by people who confused force with intelligence. But research keeps circling back to what those growers already understood. Soil structure is not improved by being ripped open over and over. Mounds warm earlier in spring. They drain better around seeds. They allow roots to enter a biologically active zone that has not just been shredded for the sake of looking worked. Below the surface, fungal threads, worm tunnels, aggregates, and microbial communities remain more intact. And look at what the alternative has done. The Midwest has lost around 57 billion metric tons of topsoil in roughly 160 years of plow agriculture. Iowa's topsoil was once 14 to 16 inches deep in many places when prairie was first broken. Roughly half of that is gone. Current erosion rates run about 25 times faster than soil forms. A University of Massachusetts study found that nearly a third of the Corn Belt, around 30 million acres, has completely lost its carbon-rich topsoil layer. That is not stewardship. That is extraction, dressed up as modernity. And once you understand that, you stop admiring the visual drama of freshly turned soil. You start asking a harder question. Why are we so attached to methods that look active? When the long-term result is a weaker system underneath, then there is another thing the old framework understood far better than modern garden retail culture does. Diversity is not decoration. Diversity does jobs. That is where companion planting comes in. And I do not mean the fluffy version of companion planting where everything just looks charming on a seed packet display. I mean functional diversity. Marigolds near vegetables because their roots can suppress nematodes and their flowers draw beneficial insects. Basil near tomatoes to help confuse and repel certain pests. Nasturtiums acting as trap crops, so aphids colonize them instead of your brassicas. Dill and fennel bringing in parasitoid wasps and lacewings because those umbrella-shaped flower clusters are basically feeding stations and landing pads for your allies. And again, the science did not make this old knowledge look silly. It made it look sharper. A 2024 study from Oaxaca, Mexico, showed that when corn is damaged by pests, it releases volatile compounds that neighboring beans can detect. The beans respond by producing nectar that attracts parasitoid wasps. Those wasps live longer on that enriched nectar and kill more caterpillars attacking the corn. The plants are not standing there helpless. They are participating in a defense system. Which means the garden is not a row of isolated victims waiting for bottled rescue. It can be built as an ecosystem with signals, traps, defenders, and partnerships already in motion. And when you do that, you are not just growing food. You are cutting out purchases. One marigold seed can do work people now try to solve with the pesticide aisle. One pocket of dill can bring in beneficial insects no spray bottle ever recruits. A more intelligent bed is often a less expensive bed. Now, if you want to see all of these principles gathered into one system, the clearest example is the three sisters: corn, beans, and squash. For the Haudenosaunee and other indigenous communities across the Americas, this was not a cute trio. It was a functioning food system. Corn rises and provides the structure. Beans climb and help contribute nitrogen. Squash spreads low, shades the soil, slows evaporation, suppresses weeds, and changes the microclimate around the bed. Above ground, they share space differently. Below ground, they forage differently too. Instead of one crop pulling in one narrow pattern, you get layered use, layered return, layered protection. Cornell scholar Dr. Jane Mount Pleasant found that Three Sisters plots can yield more than 12 million kilocalories per hectare, along with 349 kilograms of protein, enough to sustain more than 13 people per hectare per year. Iowa State research done with 4 Native American nations found that these polyculture plots produced 28 to 53% more food per unit of land than the same crops grown separately. The same work measured a 24% increase in soil biological activity and 54% less nitrate loss. Penn State research showed why the system works below ground, too. Maize roots forage shallowly, beans explore more of the vertical profile, and squash adjusts based on phosphorus availability. They are not all fighting over the same strip of soil in the same way. They are partitioning the space. That is design. That is performance. And it tells you something the monoculture mindset keeps trying to hide. Productivity does not always come from simplification. Sometimes it comes from relationship. Sometimes the strongest system is the one where each part solves a problem for the others. That is why I do not think of these as 12 old hacks. I think of them as the remains of a buried American soil system, a system that was documented, taught, tested, used in wartime, and then pushed out by an economy that made far more money selling repeated dependence than teaching resilience close to home. Keep the residue in place. Restore biology. Protect the fungal handshake. Stop tearing the soil open just to make it look worked. Let plant diversity do real labor. Build beds where cooperation reduces cost, reduces fragility, and makes the whole thing carry more of itself. That is not nostalgia. That is a household strategy. And honestly, that is what makes this feel so current to me right now. When Trump and Iran are everywhere you look and people can feel how quickly the mood of the world can turn tense again, a backyard starts looking different. Soil starts looking different. The old question comes back. What knowledge helps a household stay steadier when systems around it feel less steady? This kind does. It will not fix the whole world. I know that. But it can make a family harder to break. It can reduce how often the answer is another purchase. It can bring food knowledge back into the yard, back into the season, back into the hands of ordinary people. And if this kind of topic matters to you, hit the bell and subscribe. Because I want to keep unfolding the side of this story that goes even further, the part where gardens stop acting like needy projects and start carrying more of their own fertility, their own timing, and more of their own future. The side where a few dollars of seed can do work people now solve with repeated fertilizer purchases. The side where a garden stops resetting every season and starts compounding. So if you want that, subscribe, and I'll keep digging.